Welcome to Precalculus video lesson 3E, geometric sequences. We are going to use the formula for the sum of an infinite geometric series. A very, very cool lesson, and there are 4 boxes, so let's begin right away. Before we do begin though, I have a guess for you. I want you to take a look at this picture right here, and I want you to give me a percentage of what percentage of this picture do you believe is colored purple? What percent of this picture do you believe is colored purple? Okay, hopefully you have a good guess, and we're going to come back to this problem at the very end of the lesson. Okay, here is box number 1. The title is called The Infinite Geometric Series and Its Sum. Okay, earlier in these lessons, we already saw that the sum of a finite geometric sequence can be represented as a sub 1 multiplied by 1 minus r to the n over 1 minus r. This is an equation that we've already seen before, and we've used it for a finite geometric sequence, so that should not be anything new. But here is something interesting. If our ratio is in between -1 and 1, so for an example, like if I had a ratio of say 1/3, that's in between -1 and 1, or maybe -2/7, that's in between -1 and 1. If I have a ratio that is strictly between -1 and 1, then I am actually allowed to add a series to infinity, which is a very, very strange concept, because how can you keep adding to a sequence and go all the way to infinity and have it actually equal a number? Well, it's only true if and only if your ratio is between -1 and 1. So the formula is very, very simple. It's just the very first term divided by 1 minus the ratio. And the reason is, you should notice that it kind of looks like this, right? But the only thing that's missing is this part, right? Because everything else is still there. Well, the reason is because when you take a small number and you raise it to a very, very, very large number, it becomes essentially insignificant. So this whole thing just becomes the number 1, and you're left with the first term over 1 minus the ratio. So this is how we add to infinity. It's a very, very strange concept, but it only works if your ratio is between -1 and 1. Box number 2 is an example. It says, find the sum of the infinite geometric series. So the very first term is 3, the next term is 2, and then the third term is 4/3, and then 8/9 is the fourth term, and it keeps going all the way out to infinity. Okay, so if we're going to sum to infinity, we know that the formula is the very first term over 1 minus the ratio. Well, the very first term I know, it's pretty simple. It's 3 over 1 minus, I need the ratio. So pick any term that you want and divide off the previous term. So the ratio is 2/3. Since 2/3 is in between -1 and 1, I know that I can apply this formula. So it's going to be 3 over 1 minus 2/3. Now just doing the algebra here, I would have 3 over, I can represent the number 1 as 3 over 3 minus 2 over 3, which would then give me 3 divided by 3/3 minus 2/3 is 1/3. And then of course, when I divide two fractions, we flip and multiply, so I end up with the number 3 times 3, which is the number 9. So this entire sequence here, when you add it up to infinity, actually becomes the number 9. Okay, box number 3 is another example. We're going to find the sum of the infinite geometric series. Since we're adding to infinity, we want to go ahead and use the sum formula. So the sum to infinity is going to be the very first term over 1 minus the ratio. Well, that's going to be the very first term I can clearly see is the number 3/8. So I'll say it's 3/8 divided by 1 minus the ratio. So in order to get the ratio, I need to make sure I can take any term and divide it by the previous term. So -3/16 divided by 3/8 is going to be -3/16 multiplied by 8/3, because we flip and multiply. Notice that the 3's cancel, and 8/16 becomes 1/2. So the ratio is equal to -1/2. Now, since this ratio is between -1 and 1, we can go ahead and apply the formula. So this is going to be 3/8 over 1 minus -1/2. So I'm going to go ahead and keep doing the algebra. This gives me 3/8 all divided by, I'm going to write the number 1 as 2 over 2, and then a minus times a minus becomes a 1 over 2. So moving over here, I would get 3/8 all divided by 2 halves plus 1/2, make 3 halves. Flipping and multiplying, I would get 3/8 times 2/3. 3's cancel, and that leaves me with 1, or 2 over 8 is the same thing as 1/4. So this entire sum, when you sum out to infinity, becomes 1/4. Okay, box number 4, let's check your guess. So hopefully you remember what it was. I do want you to realize that the pink, or the purple area is all of this area here, and all of that area there, and that area there, and that area there, and so on and so forth. Well, the area of this would be 1/2 times 1/2 makes 1/4. So I have 1/4 for my very first term. 1/4 times 1/4 make 1/16. So I want to add that to 1/16. 1/8 plus, or times 1/8 would give me 1/64, and I would keep adding on, so on and so forth, all the way down to infinity. So if I want the sum to infinity, it would be the very first term over 1 minus the ratio, which in this case is 1/4 over 1 minus, and the ratio in this particular case would be 1/16 divided by 1/4 would give me 1/16 times 4 over 1, and then 4 over 16 becomes a value of 1/4. So I would get 1/4 over, change the number 1 to 4/4 minus 1/4. So coming down here, my numerator is 1/4. My denominator now is 3/4. Flipping and multiplying, I would get 1/4 times 4/3, and the 4's would cancel, and this would give me 1/3, or about 33%. So hopefully you guys got the same answer, or something close to it. So the right answer is 33%.